Okay, question number 11. Let's have Abu Bakr.
Okay. Jeff is choosing a shrub and a rose tree for his garden. At the garden center, there are 17 different types of shrubs and some rose trees. Jeff says there are 215 different ways to choose one shrub and one rose tree. Could Jeff be correct?
So how do we work? So he said there's 215 different ways. If you got two types of trees, you have a shrub one and a rose one. So many shrubs and so many roses. Well, we know there's 17 types of shrubs. So if you want to work out the number of combinations, what would we do with those two? What would you do with the number of shrubs and the number of roses to work out the total combinations?
You'd have to times them.
You would have to times them. The answer, they've given us the answer. So they've told us that they are 215 combinations. So we have to now verify that by doing a very simple calculation. What's going to be that calculation?
215 divided by 17.
Okay, 215 opposite time by 17 is divide by 17. Now, this is a calculator paper, so I'm going to jump on the calculator now. So, okay, hang on a second. Let's put the calculator on. 215 replay 17. Okay, right. Before I put the equal buttons on mine, I want everybody to send me the answers. So far, Asadullah has already sent me his answer. Jazakallah, thanks. So we got one answer already. Don't send me rounded off answers. Send me a calculator display. Okay, that's better. Okay, the rest of you as well, please. Okay, Abu Bakr. Okay, got that answer. That's okay, Salia. Okay, good, Ismail. Okay, Layla, have I got your answer? Abdullah's answer. Okay, Aisha Muhammad, is that? Aisha Muhammad, is that Lisa? Are you back in?
Who's Layla? No, Layla.
Who's Aisha?
No,
Anaya separate. Okay, good question.
Lisa.
Okay, I have a student. The name is Aisha Muhammad. Is that our Eliza? You back in the class, Aisha? Eliza?
No, it's not Eliza.
Ibrahim.
It's Ibrahim's sister.
Okay, well, Ibrahim. Okay, Ibrahim's. Okay, so we need to rename that because
Imran, it's me, Dr. Shafiullah. You asked for Aisha for a taster session
Aisha.
today. Aisha Ibrahim, she was your ex-student.
Subhanallah, yes. I forgot all about it. Sorry, but I'm just thinking myself, who is this Aisha coming in my class? Okay, no. Jazakallah, thanks for verifying who is Aisha Muhammad. Okay, no problem. You're welcome. Take care. Okay. So on the calculator, we should get 215 divided by 17. We press equals, and that gives me the same answer. So we press that button. Okay, so that gives us an answer of 12.647, blah, 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 blah. And that will give us the number of roses. Okay, so we have 17 shrub trees and 12.647 roses. So now the thing is, could Jeff be correct? So let's finish that question of Abu Bakr. So Abu Bakr, so is Jeff correct? So at the moment, we're getting now 12.647 different types of rose trees. Is that real?
Jeff can't be correct because you can't have 12.647 of a rose tree.
That's why. So we can't have a non-integer value. So the number of the number of different types of rose trees must be an integer value. So we can say here, since the number of different types of rose tree has to be an integer value, okay, Jeff is incorrect, as he has 12.647. as the number of types of rose trees. Okay, lovely. So you need to put a sentence that's pulling across on that the number of different types of rose trees must be an integer value, must be a whole number. You can't have a decimal number. That doesn't make any sense in the context of this question. Okay, lovely. Question number 12. Ismail, please join me on this one.
The points A, B, C, and D lie in order on a straight line. Work out A, B, B, C, and C, D, where A, B to B, D is to the ratio of 1 to 5. A, C, and C, D is in the ratio of 7 to 11.
Okay, so they're given us two types of ratios here. So, okay, so we have two types of ratio. So we have A to B. So what is the ratio of A to B in the first one?
Is 1.
It's 1. So let's write down 1. So this part from A to B is 1. Okay, what about B to D then?
That's 5.
So from there to there,
5.
all of this is 5 and all of this is 1. Okay, what about the next ratio? They said A to C is
7.
7. So let's always draw a diagram because the diagram helps you to visualize it. That gives you 7. And what about the C to D part?
11.
11. Now, don't worry about it physically looking like, oh, that can't be 11. According to the top one, if that one's 5, how can that one be 11? Don't worry about that for the moment, because nothing's been drawn to scale, and it's just the idea of the question for the moment. Now, if we look at the bottom question, the 7 to 11, how many parts of the ratio do we have if we have a 7 to 11 ratio?
18 parts.
Yes, we have 18 parts. Okay, what about the top ratio, the 1 to 5 one?
6 parts.
6 parts. Now, what do you think we should do in order kind of to make sense of this question? Make them equal. Okay. So we can't really do anything at the moment as it currently states. It just doesn't feel right in the question. We need to make them equivalent. So we need to make the top ones, we have to multiply everything by 3 to make equivalent to the bottom one. So then they're going to be in the same kind of, hopefully then they'll make sense. So we need to time that by 3 and time that by 3. So what would be 1 times by 3?
3.
So we'll put 3 on the top now, from there to there. And what's 5 times by 3?
15.
Okay, that's lovely. Now what's 3 at 15 now?
18.
There you go. So now it matches the bottom. And now we're kind of in the same ratio. We've got the same proportion from top to bottom. So if A to B is 3, and that's now, so if this bit here is 3, if we copy it from the top one now, and so what will be the B to C then?
4.
Fantastic. Now, how do you get the 4? What do you do?
7 minus 3.
Absolutely, 7 minus 3. Lovely. Now, if B to C is 4, and now I can also fill up here as well. If this bit is 4, so what will the C to D be then?
11.
That will be
Wait, it's on the top one.
on top one.
Yeah.
That'll be 7.
Oh, yeah.
Yeah, because B to C will be 4. C to D, we already know it's what it is. It's 11. So what is the question asking us to do now? It's saying to us, do A to B to C to D. So what is A to B now, really? What's the true value of A to B?
3.
And what's the true value of B to C?
4.
And what's the true value of C to D, which you get from the bottom or the top?
11.
Done. So this is one of those kind of strange kind of questions that you would never really do in a textbook in school. You'll always see this kind of strange variation of this kind of ratio style question given to you in an exam. So I'm just going to copy that, and I'm going to copy and paste, and okay, let's move that out of the way for the moment. And let's grab this because that's in the wrong place and move it all the way down here. And then we can grab this bit here and then we move it. Uh-oh, what's it done there? Okay, let's try that again. Okay, copy, paste, done. Sorted. And that one, we can delete it. Okay, question number 12. Okay, thank you for well done, Smilers. Question well done. Question number 13. Question number 13. The topic here is inequality regions. But in order for us to do the shaded region, understand the shaded region, we need to understand how to work out the equations of the lines involved. So what I'm going to do now, I'm going to put some colors onto this now. Just to show you the different ones. So bismillah. Everything here at the moment is in black. I'm going to try to put some colors into it. Okay, there's a red one. I'm going to put a blue line in. Blue line. Okay, and then we're going to put in a purple line. Oh, that didn't work. Because if I hold onto the pencil, it should give me a straight line. Fantastic. So now this particular question is going to have three inequalities describing the gray shaded area. And that's why we have in our question, I'll put the light on, it's hurt my eyes, it's dark. We're going to have three answers that will represent the three different lines. Now, in order for us to, I think we should start with the easiest line first. So let's bring in Mr. Asadullah, please. Asadullah, I want you to look at the purple line. And can you tell us what is the equation of the purple line just by looking at it? I don't want you to work anything out and just tell me what it is.
Y equals -2.
MashaAllah, fantastic. Y equals -2. Now, the reason why Asadullah knew that was Y equals -2 because that comes from the Y family of graphs. Any horizontal line that passes through the Y-axis horizontal line, like the purple line, it will follow a Y family. So if it goes through, don't get mixed up with the ace family. Okay, so we have, for example, if I draw a line through here, that's going to be Y equals -3. If I put a line up here, that's going to be supposed to be 4, yeah, even though it might, okay. And if I put it through the origin,
0.
Y equals 0. Okay, let's get rid of those lines because they're not part of the question, but that was just for demonstration. Okay, lovely. Now, so Asadullah, look up now. If I'm looking at the gray region looks like it's above the purple line. So how would you describe the aboveness, the above of the purple line? What would we say? And also the purple line is solid. So how would you say that in inequality language? So we would say what? So Y is, the gray region is, if it's above the line, above, that means it's more than, isn't it?
Yeah, more than equal
more
to
than
-2. Equal to -2.
Fantastic. So if we are showing any region above the purple line, because it's above the purple line, it's more than Y equals -2. So more than means more positive, like -1, 0, 1, 2. That means here, here, here. We basically saying everything above the line is greater than or equal to -2. So that's going to be one part of the answer, which we can literally write down straight away for the purple bit. Lovely. So that will explain to us the purple arrows. Okay, lovely. Right now, I need 2 more lines, the red line and the blue line.
Is a red line?
No, let's pick somebody else for that. Thank you for that, Abdullah. So Abdullah, red line's yours, mate. Go. Tell me something about the red line. That's another special family line as well. What's special about the red line?
Don't you
Okay, you
find out the grade?
Okay, now let me give you a
so
little clue here. It
you
goes through 0,
can
0, and it
find
goes through
the
2, 2,
inequality.
then it goes through 4, 4. It's a special type of line. What's it called?
Oh, it's the Y equals X one.
Fantastic. Yes, that's a special one, yeah? So I'll help you identify that by considering the 0, 0, the 2, 2, and the 4, 4. Okay, so those are points for you to look at and say, oh, hang on a second, I recognize that. That's
Yeah.
y equals x. Yeah? So you need to recognize these graphs, especially the ones which are the standard or the popular ones, like the way you kind of recognize your family members as, oh, yeah, that's my sister, that's my brother. Oh, yeah, that's my uncle. Okay, let's get rid of the little blobs. We don't need them anymore. Okay, lovely. So that's y equals x. Now, if I want to describe the gray area, so can you tell me, am I above the red line or am I below the red line? Look at the arrows, Abdullah.
Yeah.
So are we above or below the red line? Abdullah, you're cutting out. I can't hear you.
Did you not hear me?
No, we can't hear you. You're cutting in and out. Okay, I'm just gonna.
Above.
It's above. Okay, so we're gonna use the same inequality as previously. So we're gonna replace the equal sign with the inequality, because we're not saying now y equals x anymore. We are saying y equals x. We're saying y is greater than x or equal to x. So that inequality covers both, because the red line is solid. That means the red line is part of the answer. And that's important here. So that's going to be the second inequality that describes the graph. Excuse me, give me a second. I need to do something over here. Okay, lovely. So we've got one line left. So Layla, please, the blue line's yours. I think you got the exciting one.
I don't really know how to do this, but okay.
Go on. So the blue line's yours. Now, what Abdullah was mentioning earlier about working out the grade and all that kind of stuff, I think that's what you'll have to do, because Asadullah had the easier one, because that was like, he looked at it, he goes, yeah, I recognize that. That's y equals -2. And then Abdullah looked at the red one, had a little bit of hint for me. Goes, oh, yes, that's y equals x. I don't need to work that one out. I just know what it is. So,
Can't do that here.
Now, for your one, I think, I don't think you'll be able to do any of that. You're going to have to do some calculations. So, yes. Okay, so how do we work out the equation of the line? Because the gray area starts at the blue line and goes below the blue line. So we need to know the equation of the blue line. Okay, so what would we do to work out the equation of the blue line? And I will give you a little hint. So we're looking at this portion of the blue line. Sorry, can you go over there and make sure the other door's closed, please? I can still hear noise. So what would you need? What would you do this portion of the blue line? Because we need to work out the equation, and the equation has normally which format?
Y equals x plus c.
So what do you need to work out for me first?
Your gradient.
And the y-intercept.
Y-intercept, yeah.
The y-intercept is quite easy, because that's like free of charge. You just look at it. The y-intercept is here, is where the graph cuts the y-axis. That's called the y-intercept. What is the y-intercept?
1.
It's just, yeah, y-intercept equals +1. So we can put over here +1, free of charge, nice little freebie. Okay, now for the gradient, you're going to need to do a little bit of effort. So what we're going to do, we're going to put a triangle under those 2 points. Why have I chosen these 2 points? Because they go through
the graph.
They go through an exact corner. The exact corner, so it will be an exact value. I don't want you choosing this one up here and this one, which they're not going through an exact x value. They're not going through an exact y value. They're just useless. So you got to choose good points. So I wouldn't choose this, because that's not exact, no good. I would choose this one though, that's good. I wouldn't choose this point here, that's no good. But I would choose that point there. So you have to choose you have to make a decision which points are good to use, because they're going to give you exact heights and exact the lengths in the bottom, and you're going to purposely avoid the ones which are going to give you think, oh well, is that 2.1 or 2.2? Oh no, I think it's 2.3. You don't want to be doing that in the exam. You do not want to be doing the exam. You want to say, look at the graph. Oh yes, that is 2. And the, oh yeah, the bottom, oh, that is 4. You want to be absolutely certain, so that you have to know how to choose. So I've chosen for you those 2 points like a gift for you in a sense to start your question off. So how do we work out the M?
You do width divided by length. No, the other way around.
So M is equal to change in the height divided by change in the
X.
in the X, yeah. So what is the change in the Y? The change in the Y is basically, you know, a
Like
fancy word of
how
saying
many?
the height. What is the height?
2.
2. From here to there is 2.
Mhm.
Okay, right. Let me just get rid of this one again. I was making loads of mess. Okay, now, and what is the change in the X? Basically, it is the base, which is
4.
4, from 2 to 6. 4. Okay, right. So that, okay, now if I want to work out the gradient, what do we do now?
Divide them.
So you get the height, which was 2. You get the base, which was 4. Now, what's 2 divided by 4? Whatever you do, don't say 2. I'll jump out the window.
Yeah.
And that's the normal answer for most students. 2 divided by 4. Yes, sir. It's 2. What is it?
0.5.
Okay, I knew you were going to say that. I'm not too happy with 0.5. I like the half.
Half.
Okay, you can write 0.5. That kind of floats your boat. That makes you happy. Yeah.
Oh, you use it as a half X, don't you?
Fantastic. So we can say Y equals a half X, add 1. Absolutely. So I'm not doing this the slow way or the long way. This is the way that you need to do it in order to work out the equation. There's no kind of like a quick method for the blue. You got the hardest part of this question, Layla, because you actually had to do work. And the other two, they could literally look at it and say, oh yeah, I know what that is. And they could just, because of its familiarity. With your one, you have to actually say, well, hang on a second, let me work it out. Oh yeah, it's such and such. So we worked it out now. Y equals half X plus 1. So I'm going to get my blue ink here now. I'm going to label this Y is equal to half X plus 1. And right, okay. Now, if you look at the blue arrows that I've drawn here, Layla, are they above the line this time or below the line? What are they? Can you describe the arrows?
Above.
The arrows are above the blue line.
No, they're below, but.
Now that's it. If the arrows are below, does that mean it's less than the blue line or more than the blue line?
Less.
Less. Lovely. So our original equation is Y is equal to a half X add 1, but we're gonna remove the equal sign because the blue line is the equal sign and it's got to be equal and below. So what sign shall I use? Shall I use this sign or shall I use this sign?
The bottom one.
The bottom one. Okay, because that sign, that inequality has two answers in it. It has the original equal and it also has another answer which is less than. So that answer, we rapidly put that down here before anybody changes their mind and says the answer is something else. And that's what it means by write down the 3 inequalities that describe the shaded region. Okay. Right. Put your hands up next to your names if you've done these kind of questions in school so far. Inequality regions. I'm sure Ismail, you should have done this by now. Have you done these ones yet? Okay, Abdullah's done them. Good, alhamdulillah, done those questions. And Asadullah's done them as well. Asadullah, you done them as well, that's good. Okay, lovely. Right, no problem. So Layla, I'll be happy with that question now.
Yeah.
Okay, good. Okay, oh, nice, lovely question. Question number 14. Quick show of hands. Who's happy with factorizing? I mean, the whole class should be able to do factorizing. Sally, you want this one? Okie dokie, Sally's feeling brave. Okay. All right, that looks very colorful. Okie dokie, right. So Sally, question number 14, read the question first, please.
Simplify x squared minus 16 over 2x squared minus 5x minus 12.
Okay, so the key word in this question is?
Simplify.
So what does the word simplify mean in this question?
Is to break it down.
Is to break it down. So what do we start with first?
The factorizing.
And then what do we do after we factorize it?
Simplify.
Simplify, yeah, cancel it. So the simplify bit is not the first part, is not the only thing that you're doing, it's actually just, that's the easiest part of it. You have to factorize. So simplify here entails you must factorize first. Now, let's see if you can identify what type of expression you have on the top. So, Madam Aisha, please, can you make sure, I know you don't have the paper there in front of you, just copy out the questions as we go along, please, and follow us. Okay, so x squared minus 16, that's a special type of expression. What is it called? It's called the difference of two squares. Come on, what's all the nodding for? The difference of two squares. So let's just have a look at it down over here on the side. Let's take it down onto our workbench. X squared minus 16 is the same as saying what? X squared minus 4 squared. So that's called the difference. Difference means minus of two squares. Okay, now when we factorize x squared minus 4 squared, you have a special way of factorizing. What way is it? We copy the x minus 4 down. We drop the x down, drop the minus down, drop the 4 down. Then what do we do next? We repeat it. Change the second minus into a plus. Absolutely. So we have x minus 4, x plus 4. Whoa, what happened there? We had a little glitch there. Oh, that's better. So that's the top one. So the top one follows it's called the difference of two squares. A very special type of factorizing. For the difference of two squares, I've numbered it like this. Okay. So this is our taking that part of the question onto the workbench and understanding it. Okay, what about the next part? So the next part we have, let's pick a different shade. We have the bottom part of the question here. Where is it gone? Let's grab it. Okay, no. That's better. Copy, paste. Okay. 2x squared minus 5x minus 12. This is what? This is factorizing a quadratic equation, yes?
Okay, so would you find the multiple of minus 12 and then you have to add them up?
Okay, no. Remember the sentence? The sentence was, we are looking for two numbers that multiply to give you the last number and the add up to give you the middle number, the number after you've done a double smiley. Okay, folks, this double smiley is not an official mathematical term. It is just a term that I use when teaching the question, especially when we have a number coefficient of x squared bigger than 1. So we use this technique called the double smiley. And that basically stands for a partial multiplication of the double brackets. It will all become evident in a few moments. Anaya, quick question. Have you done factorizing quadratic equations where the coefficient of x squared is more than 1?
Yes, but I'm not very good at it.
Okay, so we're going to get a chance to look at it now today as well in this one question format. And then hopefully we'll do some more again later on, inshallah. Okay, now, so Salih, we're looking for two numbers. Remember, same as normal factorizing, two numbers time to give you the last number, add to give you the middle number. But here we have a little additional sentence after we've done a double smiley. So let's get cracking with this calculation. So minus 12, Salia, give me some numbers that time to give you minus 12.
1 and 12.
Minus 1 and plus 12.
And then if we
plus 1 and minus 12, then
and
minus 2 and
plus 6
or plus 2 and
minus 6
or minus 3 and
plus 4
or plus 3 and
plus minus 3.
okay, so we got to have we're having all different combinations. The 1 and 12, one's negative, the other one's positive, and vice versa. Same with the 2 and 6, same with the 3 and 4. So what I've done there, I've kind of given you like an exhaustive list of all the possibilities that how could we make two numbers at a time to give you minus 12. Now we've got to choose one of them, Salia, that when we put it into our brackets, and after we've done a little bit of double smiliness on it, it's going to give us, so we've got to start with 2x and x. The reason being 2x squared, when you split that apart, it has to be split in that particular way. Okay, that's why the 2x and x normally be x and x, but here's 2x and x. Okay, lovely. So, Salia, which one of those number ones do you want to try? Because it is going to be a little bit of trial and improvement to see which one you want to go for and if it works. So, which one, Salia?
Plus 2 minus 6.
Which one you want to try? Plus
3 and minus 4.
Okay, you want to try the plus 3? Okay, let's grab that then. Now, in where do you want me to put the plus 3? Shall I put the plus 3 next to the 2x?
Yeah.
Or shall I put the plus 3? Yeah?
Yeah.
Okay, you will try it there in that position. So, oh, I'm writing with the highlighter. Okay, plus 3 goes here. And you want me to try the minus 4 here? Okay, let's multiply them out now.
Plus 3x.
That'll give you plus 3x on the first smile.
And then minus 8x.
Minus 8x on the big smile.
Then you add them together, which is 5.
Minus 5x. So it does give us minus 5x. Yeah. So that means we've done our double smiley and the minus 5x has become evident. The minus 12 was already evident from this part here. Fantastic. So that's lovely. So we have, now we can get those and put them up here now. Let's grab them. 2x plus 3. And then x minus 4. Okay, so at the moment we're not solving anything because we are simplifying. So that's going to be, okay, right now I think we need to move it down a bit. No, we don't. That's the second part of our workbench. Okay, now what can you do now that you got everything in the right format at the top? What can you see that is possible to simplify now? What will cancel with what? Which one should we cancel? Can you see in the
minus 4 and the minus 4.
So these two?
Yeah.
Fantastic. You cancel them because it's a product on top and a product on the bottom. So x minus 4, so they will cancel. What will that leave behind for us?
X plus 4 over 2x plus 3.
X plus 4 over?
And 2x plus 3.
Now, do I need to put the brackets back in now? No. Okay, why don't we need the brackets anymore?
Because you don't have to find them.
No, because the multiplying effect of the brackets is gone. So the x plus 4 is being multiplied by another bracket. Now that's gone, it's on its own. It doesn't need the brackets anymore. You can leave the brackets in there. It won't be seen as wrong mathematically, but it'd be, I would say, slightly amateur night. So you want to show the examiner that you're a professional mathematician. So x plus 4 is the way to go. So what I'm going to do, I'm just going to do what students do, least energy, copy and paste. Obviously, you won't be able to do that in your exam because your exam won't be digital. And we literally park that question above the dotted lines, and fantastic, that question's done. So that's the amount of working out that's required to do that question properly and efficiently. So we're doing the difference of two squares for the top part. We're doing the factorizing a quadratic equation. We're using the double smiley technique on the bottom part with the full working out, and the cancelling comes right at the end. And our job is done. Okay. So Aisha, as we're going along, okay, as we're going along, Aisha, just type in some comments from question to question, how you're finding the explanations and if there's anything that, for example, that matches what you've done in school. So give me some feedback in the chat, please. All of you can do that as well. How you're finding that question. So Anaya, how does that question feel? The second part?
Yeah, it makes a lot more sense now.
Okay, now don't forget, we've done these particular questions as topics in the lesson before we've got to obviously you've joined us quite late on in the program, but we've done these as like literally 20-30 questions worth of just this by itself. So inshallah, we will be revisiting these things as part of our revision and also some topics that we haven't quite done yet. Okay, here comes the next question, which is actually one of my favorites as well, is rearranging and making subject making V the subject, for example. So let's have a show of hands. Anybody would like to take this question for me, please? First hand up gets the question. Now don't all rush at the same time. We don't want to break the internet or the chat box. Wow, mashallah, the hands are going up, flying up. Abu Bakr, of course you can do it. I said, put your hands up. You've started writing me a text. Yes, Abu Bakr, come in, please.
Okay. Make V the subject of the formula.
Okay, before you start the question, what is a little bit odd about the question before we start? Look at the highlighted bits. What's a little bit strange in the question? Normally when you make something the subject, you normally have one of them. What's a little bit strange in this question?
There's two V's on one side.
There's two V's. Yeah, regardless of which side they're on, you got two V's. So they said make something the subject, which actually happens twice. So what should be our overall idea? We've got two of them, but we ideally need them to be
on one side.
Not one side. That's not the key thing.
Oh, we just need
the
one
two
V.
V's to become
one V.
One V. That's right. That's our idea. So let's
Mhm.
write down idea. So we have we and we, or as they say in France, we. Okay, so we have we, and we want that to become one of we, or just we, like that. Okay. Right. So what should we do? Right. Give me a second. Maybe we can carry on there. Go on. What should we do
So
with the bottom one, for example?
Yeah, you get rid of that. So you times it by V.
Okay, when you say get rid of it, I mean, I'll choose a better word. We want to change, we want to move we don't want to have a V on the top and the V on the bottom. We definitely don't want to have, because that's going to cause us issues. So we want to remove the V from the bottom, from the denominator, and move it to the other side. And the process is called what? Cross multiplying.
Multiplication, yeah.
Lovely. So opposite divide by V is?
VW.
VW. Oh my God, we got cars coming in as well now. VW, I wonder whether it's a Golf. Okay, VW 15 T minus 2V. Okay, now I'm going to keep on highlighting the V's, and I want you to tell me when the V's become one. So at the moment, how many V's do we still have?
2.
So we still have 2 of them. How many do we have in the original question?
2.
Okay, lovely. So what do you want me to do now?
Expand the bracket.
Okay, lovely. I'm going to expand the bracket. Go on then. 15 times by T is?
15T minus 30V.
Beautiful. Okay, now, quick little count on the side. So, where we go? So how many V's do we still have?
2.
Okay, no problem. We still have 2 at the moment, but I know you're working towards giving me 1 V. Keep on going.
And then you'd have to plus 30 because it's a minus 30 and you move to the other side.
So you're grabbing the negative V, the smaller V, and you're taking it over to the bigger, more positive VW.
Yeah.
So it becomes a plus on the other side. So we have V, oops, I'll be back in black. Sorry about that. VW plus 30V equals 15T. So quick count. How many V's do we have still?
Still 2.
Still 2 at the moment. Well, I know you're going to get me 1 soon. Go.
And then you'd have to factorize that, which is going to be...
lovely. You said the most beautiful word there. You said factorize. Let's write that down. So the factorizing takes 2 V's and changes them into
1
V. Lovely. So at the moment, there's times in there. So we are going to pull the V's out like this. Okay, and what we left with now?
W plus 30.
Fantastic. We left whatever's actually physically left. So you drop the W down, drop the plus, drop the 30. That's a straightforward, like literally I would say, which year am I teaching that in at the moment? Factorizing. Yeah, but it's like stuff that you'd have done in year 9 or below. Okay. So that's the stuff some of my year 11s and year 9s are learning at the moment. Okay, lovely. Right. Let's do a quick count. How many V's do we have now?
1.
Okay, is that good or bad?
Good, but we haven't finished yet.
Okay, but we wanted to get to 1. Lovely.
Yeah.
So now what do we do next? How do we do the final step?
Since there's a times in between, you'd have to divide it. So it's going to be move that to the other side.
So you grab the whole bracket because it's been timed by V. We grab it, we throw it over, it becomes a
division.
So that we say V equals 15t divided by.
W plus 30.
Now you can't leave the bracket in again because now the multiplying effect is gone from the W plus 30 bracket with the V. We're not multiplying anything anymore. We don't really need the bracket. And we want to be like professional, yeah? So what's our final answer?
V equals 15t over WO plus 30.
Fantastic, lovely, well done. So let me quickly grab the copy. Lovely. Now, one thing, just quick advice, please. When you got answers, when you have like an answer part at the bottom, put your answer there. Don't be lazy and leave the answer in the middle of the page. Copy it down. That's where you're presenting the answer to the examiner. Now, the work that we've done now, what have you realized? Just look at the work, generally speaking. Let me grab a pink and just let's look roughly what's happening here. So the equal is roughly what? In a straight line. Yeah, that's just my presentation. So everything's clear. What's starting on the right moves to left now appears on the left. So everything that's moving is actually physically moving and ending up in the new place. If the W plus 30 moves to the right, it's going to end up at the right. So that's just easier on the eyes for the examiner to see what you're doing. And everything is very, very clear. You don't want to be doing work for the examiner that is a mess, and the examiner is having to go through, he's getting whiplash injuries with his eyes looking through your work, and he's having like car crashes happening with the numbers are everywhere, everything's just like he's thinking, what's going on here? It's like a tornado. So you need to make your work talk for itself, because you won't be there. You're not going to hand yourself in with the exam paper. So the examiner will only see your work. Your work has to do the talking, and you'll do the talking when you've got mathematical ability, and then you add to that the style of presentation. So it's not by just having the right answer and the right method. You've got to be able to show it, display it, advertise it, promote it in a way that's really, really clear. And the examiner has to just look at you working out, and in his eyes, within 2-3 seconds, yes, everything's fantastic. The kid understands the work. Yes, let's give him 3 marks. Yes, so I mean, I've been marking papers just recently, and sometimes it is literally, I'll think myself, this is like a puzzle. What happened where, and then scribble, and then more scribble, and a bit over here, and a bit over there, and a bit over here. See what's going on here? Keep your work consistent, keep it lined up, keep it all clear, show what you're doing, and show the working out, and inshallah, hopefully you'll get maximum marks. Okay, thank you for that, Abu Bakr. That was done very nicely, mashallah. Ooh, question 15. Okay, right. So this question is a question that involves area of a triangle, and they've given us the area. Well, that's nice. So they've given us the answer. And they want us to go back and work out the value of x, which I call these kind of questions a reverse question, because they've given you the answer. They want you to go backwards and work out what the original question was. So, right, I need a brave soul to take over this question. Right, who's ready for question number 15? Okay. Okay, no, mashallah, all the hands are all firmly down. Okay. Okay, Abu Bakr, you can mute up for the moment, Jazakallah khair. I'm gonna have to select a person because they're all feeling a little bit shy today. Oh, maybe because they're going out of lockdown back into school and they're feeling a bit shy. Ismail put his hand up, mashallah. He saved the day, young man. Okay, Ismail, we can do this last question before we go for our break. So, join me, Ismail.
The area of a triangle ABC equals 6√2 meters squared. Calculate the value of x. Give your answer correct with 3 significant figures.
Okay. So this question is a question to do with what topic?
Half AB sine C.
Okay, so this is the question. The topic is areas of
Triangle.
a triangle, and the triangle is a non-right angle triangle. So we can't use base times by height to divide by 2, which would have been nice. Okay, so which formula are we going to be using for this special type of triangle?
Half AB sine C.
Okay, area equals half AB sine C. Now, in that particular question, if I was to redraw the question, so these, let me tell you what the letters are, because our lettering on our triangle doesn't actually match the lettering on the formula. Now, this is the point I want to just stop there for a moment. We can actually relabel the diagram to match our formulas labeling. Okay, so I'm going to give you the permission to relabel my diagram. When I say relabel, I mean relabel the names of the corners. So according to your formula, so we'll just, which is the C?
The angle.
So can I just do this for the moment, yeah? Can I
Yeah.
proceed there?
Yeah.
So according to your formula, the C must be where the angle is. Lovely.
Yeah.
Okay. So according to your formula which you're giving me here, this formula, okay, this lovely formula here. What is the A and the B then?
The x plus 3 meters and 2x minus 1.
So then that actually matches our formula. So this one we can do a little bit of adjustment to it and we call it
B.
Okay. So that's not going to hurt the question. The examiner's not going to get annoyed with that. That just helps us to connect our formula with the triangle they've given us, and the labeling, everything matches now, and everything should be nice, and it should be flow more. We will hopefully get less confusion between the letters of the original question and how the lettering in the formula connects to the triangle. So should we put everything in? Yeah?
Yeah.
Okay, so where does this part go? This part, where does that go?
Where A is.
Fantastic.
area on the left
Fantastic.
side.
Yes, that goes there. So you put the answer in. Lovely.
Yeah.
Half is half. And what about, what's A?
Plus 3 meters. X plus 3.
A is?
X plus 3.
Lovely. And what's B?
2x minus 1.
And what's the value of angle C?
45.
Fantastic. Lovely. Okay, I'm just going to stop there for a moment. I want everybody just to kind of catch up with where I am, because this question, I'm just going to give you a few seconds for everybody to catch up. Please put your hands up next to your name, just to quickly indicate that you've kind of got up to that level and you're happy and you've got any questions. Fire away. Anybody else? Okay, Layla, you got, okay, you happy? Anybody got any questions? Open your mic, ask question. Anything that you don't understand. Okay, so everybody's got their hands up, alhamdulillah. Okay, good. So this is the formula. It's a special formula for non-right angle triangles, and it is a formula where you need to know the one side and the other side of a given angle. So you got to know the angle, and you got to know the values of the two sides, either side of the angle. If you have that situation, then you can use this lovely and beautiful formula here. Tolo, whose phone's that? My phone. Where's my phone? Where's something's buzzing somewhere? Okay, folks, just give me 1 second. Something's buzzing somewhere. I can't see anything here. What was it?
Your phone? It's not my phone.
All right, where did it go? Okay, leave it. Don't worry about it. Okay, right. Ismail, let's do some smashing. What are we gonna do now?
You times by 2.
Time it. Okay, so you want me to take the 2 over?
Yeah.
Okay, what do we get now then?
12 root 2.
Okay, so okay, what's happened there? Give me 1 second. Blah, blah, blah. Half time by that goes down there.
Say, screen's frozen for me.
Okay, sorry. Can you see the screen?
Yeah, I can see a mouse moving.
Oh, that's
on your
fine.
cursor.
Then it hasn't frozen in that case. Okay, so the 2 is going to go up where? To the top. So
Yeah.
we're going to have now 12 root 2 equals
X plus 3.
equals
by
x
2.
plus 3. Okay, now let's multiply them out rather than keep writing them out again.
Okay.
So what's x plus 3? Now multiply this double brackets for me, please. X times by 2x is
2x squared
2x squared, and x times by minus 1 is
minus x
minus x, and 3 times by 2x is, and 3 times by minus 1 is.
minus 3.
Now, the sign of 45 should be a special number. So if type in sign 45 on the calculator, close the bracket, it gives you, what does it give us?
Root 2 over 2.
Root 2 over 2. So we've already moved the 2. What can we move now?
Divide it.
So we can move the other 2 as well, that way.
Oh yeah,
And move the root 2 which way?
that way.
That
Divide
way.
it.
So on the left hand side, you're now going to have 12 root 2 times by 2 and divided by.
Root 2.
So we can do cancel, cancel. So that leaves us what on the left hand side?
24.
24. And on the right hand side, which is this one here, can you simplify that for me, please? 2x squared
plus 5x minus 3.
Beautiful. Now, this looks really nice, like a quadratic equation that we just done earlier, but it's got like a 24 hanging about on the left hand side. What should we do with it?
You have to minus.
So you bring it into the family. So what you're doing is standing outside the front door. Come inside is Eid. So opposite add 24 is?
Minus 24.
Minus 24. So we say 0 equals 2x squared plus 5x minus 3 minus 24 gives us?
Minus 27.
Minus 27. Okay, so that's all looking like nice and tidy and ready to be done in a quadratic equation now. One thing that we forgot to mention, which is very, very important in this question, and I'm going to highlight it into pink over here. I don't know whether pink is the correct one to choose. All right, give your answer correct to
3 significant figures.
Okay, so what's the kind of the relevance of that? What are the total? Why have they mentioned to 3 significant figures normally? Give the answer.
Because it means the involvement of a calculator, so we're going to use quadratic formula.
Okay, let's write that down. That means you must use a calculator, i.e. you're going to be using what formula?
Quadratic.
The quadratic formula to work this question out. So this question is not going to be one that you can factorize by using the double smiley method that we used earlier over here. So this one was a nice one, which we could do. And the indication wasn't that they didn't tell us to do anything to significant figure or anything else. So that's the clue. 3 significant figures is a clue to, we want you to use a calculator and use a calculator method for finding the answer. So 2x squared plus 5x minus 27. Let's put the template underneath it, Ismail. So that's going to be ax squared plus bx plus.
Let's see.
So what's my a value? State it to me.
A is 2.
And what's my b value? State it to me.
5.
And what's my c value?
Minus 27.
Beautiful. You must write these 3 numbers down. Write them down to the side because you are telling yourself these are my numbers. Because when you're going to be in exam, sometimes you're in a state of like anxiety and you're kind of rushing or you're getting worried. Write the numbers down. It's like a present for yourself. You're telling yourself, oh, I've got these 3 numbers. Now let's put them into the correct formula. Give me the formula again. It's hidden on the top of the page. Give me the formula.
Minus b plus or minus b squared minus root b squared minus 4ac over 2a.
Now, one of the most important parts here in the question is how, once we put the numbers into the formula, how we put them in the calculator, which is right next to us on the left-hand side of the screen, class with Casio. That is imperative that you put the values into the calculator correctly. Otherwise, you're going to end up on the moon eating cheese. And there's no doubt about that. Okay, let's put the numbers in. So we say now, okay, I think I might need to borrow that and put it, give me a second, because I've taken a little bit too much space. I might need to shrink it a bit. Oh, oops, I'm using, give me a second. Oh, okay, let me grab it from here. You can't quite see what I'm doing at the moment. Okay, that's better. Got more space now. So, okay. So what's your b value? -5 plus minus, yes?
Yeah.
5 squared
-4
time by 2 time
2
by
times -27 over 2
minus
times 2.
27. Okay, lovely. And the square root goes here, is that right? Divided by 2 times by 2, is that correct?
Yeah.
Okay, now here comes this is the piezo de resistance. This is the key thing. Everybody, please focus on the Casio class with our emulator on the left hand side, please. Focus your eyes on that. And I will lead you through it button by button. So hopefully, if you got one of these type of calculators, how do you have one? Calculator. Okay, right. So nice and slowly, first of all, we need to press, if you follow the mouse, we need to press the fraction button. And now for the minus that we have here, we need to use it. I call this the baby minus. Little minus here, this one with the mouse is. And then you press 5. Now the plus or minus, that's what we're going to do. We can't put both of them at the same time. It won't work. So we got to do one by one. So you put plus first. Square root button. Square root button's here. Now it's 5 squared. Now it's takeaway. So we use the normal big takeaway. It's actually physically big on the calculator. Takeaway. Now we're going to take away all of that. Now what we could do here, just to make it a little bit simpler, is put a little bit, because we're going to take away all of that. So we're going to take away, we'll put a little bracket here, 4 times by 2 times by now. So we don't crash the little minus into the times and get the whole calculation to get us math error. We're going to put another little bracket here, minus 27. Now when you close the bracket, go close the bracket twice. Okay, and then we press replay and we bring the cursor down to the bottom. And yeah, we don't need to write down 2 times by 2, but we are literally copying what we see here on the left-hand side into the calculator, literally like for like. We're not leaving anything out. And if we press equal, inshallah, hopefully, we should get an answer that looks like that. Now, don't worry about the answer looking all a little bit kind of hairy and scary. Okay. Let's write it down as it is. And don't do anything else. That's my x1 value. So if you press SD, it gives you a value of x1 equals 2.63. Press the SD button, please, folks, to change in decimal. 1, whoops. 1,
That's it, you don't need to do anything.
answer. 1,043,674. Okay. Now, don't forget we get 2 answers. So for the second answer, it could be another positive answer, but we're gonna have to go and check. So I want you now use the replay button and literally get the cursor to go back up and like feed it back to where the plus is. So everybody look over here and change that plus now. Press del, take it back and put the normal takeaway in there. So we put in the minus in there now. Press equal again. And it gives you that, which is that. Now there's a reason why I've done both answers, because when you solve a quadratic equation, you normally get 2 roots. You can get one root as well. If you touch it, that's called a repeated root, or you can get no roots. That's called a complex. And that's basically taking us into A-level maths. Now, so Ismail, I want you to look at the 2 answers and tell me which answer is the one that we're going to submit, because one of them is actually incorrect. Which answer shall we use? Top one, bottom one?
The top one, sorry, x1.
Okay, so oops, sorry, I want to use highlighter. So you want me to select this answer here, is that right?
Yeah.
And you're going to round the answer for me. And what's the answer after you rounded it to 3 decimal? Is it 3 SF?
2.63.
1, 2, 3 SF. So then we look at the 1. Because the 1 is less than 5, we leave everything alone. So the answer becomes
2.6.
now Can you explain to the class, please, why you ignored the bottom one and why the bottom one is irrelevant, even though it's mathematically correct for the question that we've done? Why is it irrelevant in the context of this triangle question? You have to
Because it's a
explain.
minus.
Okay, so if x2 is minus, what does it mean? Minus what? Minus meters?
You can't have a length going down, like below
Exactly.
0.
We cannot have a negative length. We cannot have a negative length. So length is a positive quantity. So even though mathematically we get two solutions to the equation, but one is relevant and one is irrelevant, one doesn't make any sense. So 2.63 is selected on purpose. We do not put minus 5.13. We do not put that down. That will crash the question. Don't put the second answer down. So the second answer is just for our information, but it is not the answer that we submit to the examiner. And that question was done beautifully. Ismail, Jazakallah khair. I think it's time for our break time. So we have normally a 10-minute break. So, wait a second. Oh, my time has died. Well, we can pause our recording. Okay, so question number 16. Anybody recognize this topic? First of all, type it into the chat, please. What you think this topic is, type it in. Okay, Abu Bakr, well done. Excellent. Ismail, well done. Excellent, correct. Okay, so we got 2 students in the class that know what this topic means. Okay. Aisha, yeah, that is the topic. That's a very general word, Aisha, for this topic, because algebra actually covers a lot of maths. Yeah. Okie dokie. Abdullah, mashallah. Okay, no problem, mashallah. We will reveal it all. Okay. Okay, close. Right, let's have Abu Bakr, please join me on this question. Question number 16 is your question, young man.
Using x n plus 1 equals minus 2 minus 4 over x squared n with x equal to the power of 0. Now x0 equals minus 2/5. Find the value of x1, x2, and x3.
Okay, I just want to first of all apologize to everybody in the class. This topic is, I think, it's overly difficult by all the symbols. It just kind of, it's a little bit confusing to kind of get your head around all this stuff. It's actually really quite straightforward, but just that the way they've set it out. Okay, right, let's just quickly clear our screen on the Casio ClassWiz emulator. Okay, so what we're going to be doing is we are going to be substituting this value into here.
Yeah.
And substituting this value into there.
Mm-hmm.
Okay, and then what we do when we get our answer, we substitute the answer back into the question. So we just keep refeeding the question in until we generate x1, because we're starting with, this is our start. So we start with x0. So just think about it like so we have x0, then that's gonna generate x1, then x1 is gonna generate x2, and then x2 is gonna generate x3. So these are like 3 values. So we are putting this, we're trying to get closer and closer to the answer. So iteration. So let's start with x0. Let's copy out the top question. I need to do some little bit of rubbing, make it a little bit nicer. Let's do a bit of cutting. Copy, paste. So x0. If you put in x0 into here, then we have to add 1 to it. What's x0 plus 1?
x1.
Lovely. So x0 leads to x1. Now, the x0 is actually that value. Where does that value go in?
To the bottom bit.
Into the bottom bit as x0. So it'll be, okay, minus 2, minus 4 over
minus 2.5 squared.
Okay. So we are substituting our starting value of x0, which has a physical manifestation of minus 2.5 into the x. Okay, so we put that into the formula to start the formula off. Okay, it's like putting the key into the ignition. Then we turn it, and when we turn it, we get an answer, which is here. So now I want everybody to get onto the calculators, please, and follow me on our entry into the calculator. So minus 2, again, I will definitely say we use a little baby minus in brackets, minus 2. And then we're going to take away, so we can use the big takeaway, and then we use a fraction button. Okay, 4 on the top. Press this button is replay button. It brings the cursor to the bottom. Now you can put brackets. In one sense, even if you didn't put the minus into the calculation, the answer will be the same. But for the sake of argument, I want to literally type in what we see. The little baby minus again. I hope you all pressing the baby minus, Alia. Come on. I've got one doctor sitting across me, and she's just sitting there staring at the screen. Doctors of the future. Okay, so hopefully what you see here on the emulator should be identical to what you see here in black over here. So hopefully we press equal, we won't get anything crazy, and we get that answer. So I've got minus 66 over 25. Okay, at the moment, I'm not really willing to round that off or do anything crazy with that, because I'm going to be putting that into the next one now. So remember, we started off by putting into here x0. That has now generated x1. So we started with x0, we got x1 now. In order for us to work out x2, I've got to put x1 back into the formula. So let's change color. So we can grab this, and we can do it again. So let me do another one. Okay.
Sir,
G.
wouldn't it be easier for you to press SD and then it'll become a decimal, and then you put that into replace that with minus 2.5?
We at the moment, to tell you the truth, yes, we can do that. Let's do that actually. Let's
Okay.
press the SD. That gives us actually. I was unnecessarily worried that it's going to give us a really big number. It's actually a nice little, quite a harmless little minus 2.64, which will actually help us fill it here into the card. So we can literally quickly put that down. Okay, right. Give me a moment while I just copy out the equation again. Oh, what am I doing? I'm trying to copy out with the rubber. Okay, copy, paste. Okay, and put that off a bit and do back to blue. Okay, and get rid of that. Okay, so we're gonna put in the x1 value into here. So what happens if we put x1 into n? So what's 1 add 1?
2.
X2. It gives you the x2 value. So it'll be now minus 2 minus 4 over the x2 value, which is, so the x1 value will go into there. So we put in there, what should we put in there? Minus 2.64?
Yeah.
Okay, lovely. So we go to the calculator. Now we can restart the question. Okay, or we can do a little bit of tinkering. We can go to press replay. And we go down. And we go down a bit. And then what was the number again? 2.64.
Yeah, minus 2.64.
Yeah, we can literally go back and edit our original question without having to put all the effort in typing everything back out again. Okay, and then we press equal. It's giving us something even more nicer. And what shall I press now?
You should press SD, but I think it'll become a bigger number. Yeah.
That's not a problem. Okay, so we got here minus 2.5 7392 Okay, and then it kind of goes on and on. Now, for some reason, I mean, in the mark scheme, that's as much as they want. I'm sure if you wrote extra, that wouldn't be a problem. But in the mark scheme, they've literally gone as far as that many number of decimal places. Okay, and that would be quite okay for us to put it like that. And we don't necessarily need to put that dot on there because we're not writing the rest of the number from where it's recurring to where it's recurring to. So, okay, we need to copy out. Just copy and paste. Okay. Oh, I don't want that one there. What do we do now with that value?
We place it into the answer, into the bottom here, over there.
Okay, so now we're going to put in now the 2 for the n. What happens if you put the second value back into the formula? 2 out of 1 gives us what?
3.
This is the third value. So we've done that as well. Okay, so it's equal to -2 -4 over. Now we can type in -2.57. I'm going to show you a little trick here. Okay, that we can do for the question, so we don't have to remember all that number, and then we have to square it. I'm just going to go back and check something. I forgot to write down squared here. Nobody picked it up. Okay, class, please be vigilant. If I make any mistakes in writing statement, please politely correct the mistake, because otherwise it'll get recorded and it'll go on to YouTube, and then people will be misinformed. So I remember a time the students were actually giving me wrong answers. I was writing wrong answers down from the students. That was hilarious. And then finally, after I uploaded the video, that the answers I was given in the class were actually incorrect. So alhamdulillah, I got my own calculator now, nice and big, class whiz. Hopefully that should help us. Okay, x3 equals. Now, how do we put in all this? So I want everybody to look over here. Look where my mouse is. I want, how do you put all of that number into the calculator for the next part of the calculation without making a dog's dinner of it?
Use
So
answer.
we need to write in there the answer. Now, the calculation has already been set, so I'm going to try to go up here. Uh-oh, what done? Oh, I think I've just messed it up by pressing some wrong button. Okie dokie, right. I need to generate that number again. What was
I think it's fine. I think it's fine.
I need to go back and change that number to generate. Okay, so let's delete that and put in there 2.64. Yes. So I'm just kind of a little bit backtracking. Oh, there's my number. So this number here, by the way, is stored into the calculator memory. This number here. So I want to reuse that number, which is actually this big ugly number, without having to memorize it all and the rest of it that goes on to infinity. So I am going to now do a new calculation, literally a new one. So I'm going to do -2, take away brackets, so a fraction, and then we're going to have 4, replay, and on the bottom, I'm going to press this button here, answer squared. Now this is very important that you know how to use the calculator has automatically memory for that value, so I don't need to memorize it. And then hopefully when I press equal, it'll give me a beautiful answer with no kind of rounding errors, because I've created the rounding errors by my own rounding. So there we go. That gives us now -2 points. Okay, let's write that down in red ink. So x -2.6037672555, and apparently that's what they've actually got written down here. That's what the examiner actually wants to see. 6. Okay, let me make sure I write it down right. x1, x2, x3. We got all the numbers. Okay, so this is the topic that we definitely have to study. We haven't done this one so far. We need to spend some time on this. Okay, Question part B now, Abu Bakr. Can you help me with that, please?
So it looks kind of confusing.
Now,
to me.
what is, so here we need to explain what the iteration actually is. What is iteration helping us to get to? So the number we find each time, so iteration is an estimation of a solution.
Oh, yeah, an estimate.
Because we're getting closer and closer each time
Mhm.
of a solution. The iteration is a rearrangement of also the original equation. That looks horrible. The iteration. And that would be enough for us to get the 2 marks for that. That's explaining what the nature of an iteration actually is. Solly, you're having fun. Back hurts. Okay, copy that down. Abdullah's got his hand. Abdullah, can you put your hand down, please? Aisha's asking a question, is doing all this going to ruin your brain cells eventually? Hopefully not. Hopefully not. Okay, right.
Trying to keep it all in.
Trying to keep it all in there. Okay, give me a second. Okay, lovely. Question number 17. Everybody feast your eyes on question number 17. Okay, what topic is question number 17? Please type it into the chat. Let's see if you can actually recognize what the topic is. And the topic actually isn't average speed, by the way.
Great.
What do you think is, Alia?
Okay.
Okay, nobody's given any answer so far in the chat. What's the next topic? Everybody, wakey, wakey, Anaya. Write anything down.
Problem.
Yeah. Okay, so Layla's given me a topic. Okay, I'm not going to say it out loud because let's see what everybody else says. No, Layla, it's okay. You had to go. That's good. Come on, Salo. Okay, Abdullah. Okay, Abdullah, you're giving roughly the same answer as Layla. Ismail's giving me the obvious answer that it's a speed question. Okay.
Greater than.
Okay, Aisha's okay. Whoa.
Is it working at the greater than stuff?
Okay, right. Right. Okay. Anaya, I haven't got an answer from you yet. Give me an answer. You can say average speed if you want to. I said in the beginning, don't say it, but you can. What do you think this topic's about? Come on. Okay, Anaya's given the most politically, mathematically, what's the word, vague answer possible. She goes, it's a maths question. Of course it's a maths question, girl. Yeah, but that's not the topic. Okay, I don't think anybody caught the topic. So I'll put you all out of your misery.
It's not the greater than the left one. Our intervals.
Okay, hopefully you can see what the topic is about. Okay, so I need Layla. Okay, no, let's have Anaya because I think she probably could sleep soon if I don't call her. Anaya, join me on this question. Wake up from your slumber, rub your eyes. You can do it. I'll help you. Come on.
Okay, a train travelled along the track in 110 minutes. Collected the nearest 5 minutes. Yeah. Jack finds out that the track is 270 kilometers long. He assumes that the track has been measured correct to the nearest 10 kilometers. Could the average speed of the train have been greater than 160 kilometers per hour? You must show how you get your answer.
Okay, lovely, lovely. Okay, so let's have a blue line. And let's have a purple line. Nice and big, big, big. I don't know whether they need to be that big, but okay, okay, I hear you say it doesn't need to be that big. Yeah, let's make it smaller. Let's save some space. Okay, lovely. Let's do some highlighting, color coding. Okay, so we have blue for blue. We have green for green. Okay, so the train travels along the track in 110 minutes. So let's put the 110 in the middle. Is measured correct to the nearest 5 minutes. So if it's measured like in nearest 5 minutes, what will be the next measurement and the previous measurement?
115 and 105.
Beautiful answers. Fantastic. Okay, the green bit now. Put 270 in the middle. And it's measured correct to the nearest 10 kilometers. So what will be the one ahead and the one behind?
280 and 260.
Fantastic. Now, whenever we do an error, our error is going to be, okay. So it's going to be to the nearest 5. That's going to be 5. So there'll be 2.5 kilometers here and 2.5 there. 2.5 minutes, sorry. Take that bit off. And similarly here. So I need you to establish for me what the minimum value here and the maximum value of this is the time part. So what could have been the minimum time?
107 minutes, 0.5.
Beautiful. And what could be the maximum one?
112.5.
So you literally working at the middle of those 110, 115, 105, 110. Basically, you've done, you've minus them, divided by 2 and added on, or you can just add the two numbers and average them. But yes, you could probably just look and say, yes, I know what those values are. So that's going to be my time min. That's going to be my time max. Or we say this is the time lower bound, or this is the time upper bound. Okay, now there's some technical points here that we need to be careful about. So now if I get rid of the actual if I can actually get rid of this top part here and just show you what I mean by the technical part of this question is. $107.5 is actually a value that we can consider, because the moment you reach 107.5, the number will round to 110. Whereas on the other hand, the 112.5, technically, if you reach 112.5, you won't round it down to 110. It's at the boundary. It's really everything less than 112.5. But for the sake of this particular question, we are being allowed to use the 112.5 as literally the ultimate maximum value. But we can also use numbers like 112.4999. For those of you who want to be that kind of precise, you can do that as well. So I'm just kind of pointing that out to you. The examiner has allowed us to use those values, even though technically you wouldn't use 112.5 to be rounded to 110. And the same for the next one. So what is the minimum? Give me what's that one called? The green one. The green one is distance, isn't it? So this is our distance. So Anaya, can you tell me the lower bound distance and the upper bound distance?
265 and 275.
265 is your, what's that called? Distance lower. And that one will be 275 with the distance upper. The maximum could have been up to that number. Okay, so now if you want to work out now the question is actually asking us to do what? What do they want us to work out in the question?
The average speed.
Average speed. So talk to me about average speed.
Um,
Average speed is equal to
the mean. No, yeah.
distance
Distance over time.
divided by time. Now, they want us literally, when they say greater than 160, what do you think they're indicating here? Do they want us to work at the speed upper, or do they want us to work at the speed lower bound? Now, I'm not actually work at the upper, the speed upper. So which one do they want us to do here? By them, and the key word is here.
The upper bound.
The upper bound, absolutely. They want us to work at the speed. What could have been the maximum? Could it have been more than this number? So they want us to kind of take the speed up as much as possible. Now, if we do a speed upper, so tell me here. So tell me what goes into these little boxes. Is it distance upper, distance lower, time upper, time lower? How do I get the upper? How do I get the maximum speed from a division question by that? Do I make the top number as big as possible, small as possible, the bottom number? So talk to me about what goes into the little rectangles.
Do you write upper? Or
Absolutely. So you do the distance upper, you put the biggest possible number on top, and what do you do on the bottom?
oh, yeah.
I'll keep the words consistent. The lower bound, the smallest possible time. So let's grab the right numbers now. So the biggest possible distance is, what is it?
275.
And the smallest possible time is?
107.5.
So let's use those numbers then in our calculation. So 275 goes on the top, and 107.5 goes on the bottom. Okay, so we've got a calculator already ready for us. Use the fraction button if you want to. Type it in, please, everybody. Wakey, wakey. Don't go to sleep. And don't wait for other people to do it for you. Okay. So SD. Whoa. 2.5. Oh my God. Blah, 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 blah. Okay, now what have we just worked out, by the way? So think about the units of the question. They want us to work at the average speed of kilometers per hour. We've actually worked out kilometers per. Can I say it, Salia? Kilometers per minute. Because the questions do the minutes and kilometers in the original part, but the answer is being kilometers per hour. We're changing kilometers per minute into kilometers per hour. So what is the simple conversion that we do? Times it by 60. Since we got the calculator already fed in, we just literally hit time by, it automatically uses answer, times it by 60, because that will give us an answer of that. So we now have 6600 over 43 equals, press the SD button. So that gives you 153.488 blah, 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 kilometers per hour. So the time by 60 is absolutely important. You must do the time by 60 to convert kilometers per minute, kilometer per hour. Okay, so, okie dokie. Now, it says that, so, and I finished the question off us then. So they said, could it be more than 160? So we've maxed out the speed by doing speed upper. So what was our speed? Was our speed more than 160?
No.
No, so give me like a little sentence then. So we need to make a statement. So first of all, I think I've written this a little bit too big. And let's make it smaller. And move it around here. So time for sentence now.
Okay.
As the question says there, could the average speed, they're asking you a question. You must show how you get your answer. We got an answer, and our answer, I'm gonna underline it. And so that is obviously less than 160, but I need you kind of type the 153.488, and I want you to type this greater than 160. Give me a nice sentence. Think about the sentence. Okay, now while you're thinking about sentence, I want everybody in the class to type in the sentence for me, please, on the chat. Everybody have a go at how you would express yourself in English. Go. I'm gonna give everybody 1 minute.
You had to write it ourselves.
You write to yourselves. Give me a sentence. So the question is, could the average speed of the train be greater than 160? The answer is, the maximum average speed possible is, also on, oh, sorry, I'm giving Paul the answer. I'm waiting for nice, lovely sentences. I haven't seen any so far. It's literally what I've just said in the last 20 seconds. Write it up, press enter, send it through. I want to see what everybody's effort is. Oh, Asadullah, your answer is, what are you talking about, Asadullah? Type, type, type. Come on, children. Everybody should be good at typing. Typing is what students are good at. Typing, texting. Okay, no. Oh, wow. Abu Bakr, I think you're answering the B part. I wanted an answer for the top part. Ooh, Ismail, mashallah. That's good. Okay. Okay, Nayan, mashallah, good. Ah. Okay. Right, let's write some of those down. Good. I've got some nice answers from some of you. Okay, let's write it down. So we're gonna say the maximum, okay. The maximum average speed is approximately 153.488 kilometers per hour, which is less than 160 kilometers per hour and not more than. Oops. Fantastic. Some nice, lovely answers there. I think Abu Bakr, you answered the next part of the question, which is good. Okay, Abu Bakr, read the next part of the question for me, please. Go.
Jack's assumption was wrong. The track was measured to correct the nearest 5 kilometers. Explain how this could affect your decision in part A.
So if we're going to have a different value for the distance now, it won't be till 275, it'll be a smaller number because we're doing to the nearest 5 rather than nearest 10. So if we decrease the distance, what will happen to the speed with a smaller distance? Will the speed stay the same, go up, go down?
It would go down.
Obviously, the speed will go down.
Mm-hmm.
Let's write that down. The speed. Okay. Oh yeah, I'm going to try something here at the moment. Okay, let me try this. I'm going to try something. So the speed will be lower. As there will be less distance.
Are you typing it in the keyboard?
No. I'm not typing at all. It's called Scribble. Who knows about Scribble on an iPad? Nobody? Okay, Scribble is where you write in handwriting, it converts into text for you. Yeah, you're sick. That's what they charge you £1,000 for the pleasure of doing the sickness. Okay, right. Fantastic. Abu Bakr, thank you for that. Who's doing the beginning part? I think it was Naya. Naya, well done, mashallah, for your contributions so far, mashallah, on that question. Well done. You've done the handle out really nicely. Okay. Right, I don't know if they have time to finish that one off completely. Or that one. Oh, I think I'll do a graph for that one in advance. You don't worry, all the questions, we will come back and finish them all off. So I think we should, number 18 looks a little bit longer. Let me have a look how big 18 is. 18 isn't too big. No, not really. And 19 is probably a little bit smaller. I think we'll just skip 18. We will come back to 18. Nobody next, inshallah. Although I'm just thinking about which question we can fit in the time that we have in front of us, inshallah. So let's try to smash number 19. Okay, question number 19. Let's have Madam Layla. Layla, please join me.
Okay. Solve 2x squared plus 3x minus 2 is more than 0.
Okay, now normally, what normally be is here instead of more than what normally be is there?
Equal to.
That's what we've been doing for like forever in school. Equal to. So the more than, it has a significant, but is only when we draw it graphically will it help us to see what that significant is. At the moment, what I'll say to you is, let's not get too hooked up on the most significant part of the question, which is this part here. That's very important, actually. So we're going to be, but I want you to look at what you're familiar with. That's what we're not familiar with. That's not normally how we do a question. Are you familiar with this bit here?
Yes.
Lovely. Okay, let's tear that part. Let's have a look at that question. So we're going to be, in order for us to solve that quadratic equation more than 0, what do we need to do first, second, third? Give me some ideas. We need to
do the quadratic equation first and find what your x's are.
So we need to do what to the quadratic equation?
Factorize.
And then what do we do after we factorize?
Solve.
And then what we need to do is to kind of help us to visualize the question.
Graphical representation.
Okay, and then what do we do? And then we can answer
the question.
Using what?
Using inequalities.
Because the question is actually about inequalities.
Yeah.
So we're going to do what we are familiar with, which is this and this. We're going to do a bit of this to help us. And then we're going to do this here to actually complete the question. So that's the foundation of how you do the question. Two fantastically, hopefully familiar parts of the question, and other two parts a little bit new, a little bit different. And we're going to hopefully look at the question like that. So let me get rid of this bit here. Let me cut it out for the moment. Copy, paste it here. Okay, right. So tell us, please, how do we factorize this equation? Take in consideration, we've just done one similar earlier. So we're looking for two numbers that
add to make -2. No, multiply to make -2 and add to make 3.
Multiply to make -2, absolutely. And then add to make what?
+3.
After we've done a double
smiley.
Double smiley. You must add that on to your definition. Otherwise, if you don't add that on, then what you said is correct, but only correct for questions that don't have a 2 in front of it. Okay? Because we have a 2 in front of it, we have to say the word double smiley. That's a technique that I've taught you. Partial multiplication of the brackets. So don't try to find that in any books, by the way. Don't go, please, why would you don't go to school and ask your teachers, by the way, I've learned the double smiley method. They'll be thinking, yeah, what's the double smiley? Have you gone mad? Yeah, they're gonna think you gone mad. So please, that's just a very unique thing to me. The -2, give me the factors of -2, please.
1 and -2 and -2 and 1. I mean, Yeah,
So
plus
we
2.
swap them around. Okay, lovely. So let's put down the 2x. Boom, boom. Okay, so we got to choose one of those. Which one shall I choose? Top one, bottom one?
Bottom.
Are you sure?
Wait, never mind the top one.
Okay. We choose the top one. Where shall I put the plus 2 first of all? Where shall I land it? Shall I put the plus 2 opposite 2x or next to the 2x?
Opposite the 2x.
Beautiful. And then the minus 1 goes here. Lovely.
Yes.
So let's do the double smiley to check that we get the plus 3. So what's minus 1 times by x?
Minus 1x.
And what's 2x times by plus 2?
4x.
And what's 4x minus x?
3x.
So as the double smiley worked?
Yeah.
Yes, so that part's worked and the double smileys worked as well to give us the 3x in the middle. Fantastic, lovely. So now what we need to do is we need to solve it. Okay, so we've done the factorizing, we need to solve it now. Remember at the moment the inequality will kick in at the end. So what do we do with the x plus 2?
You just make that
Equal
x
to 0, yeah?
plus 2.
Therefore, x will be equal to?
Minus 2.
Fantastic. And that one you can just do by visual, just by looking at it, or x is x plus 2, so x must be minus 2. So our intention here is to make each bracket equal to 0. Okay, now what about the other bracket, the 2x minus 1? What happens when you make that bracket equal to 0 in the process of trying to solve it?
You have to isolate x, so you divide it by 2.
So you move the minus 1 becomes a plus 1, opposite time by 2, divide by 2,
Over 2, yeah.
so we get half. Is that right?
Yeah.
Okay, lovely. So we can call that x1, x2, and here's a graph that I done for you earlier. I used one of the graphing apps on my iPad. So there's your a half value, and there's your minus 2 value. And that's what we just worked out from the pen and paper method. There's the minus 2, there's the plus a half. These are called the roots of the quadratic equation. If roots meaning the point where the graph intersects the x-axis. Now, here comes the interesting part. Normally, we will be doing this graph. Oops, something there. No, don't do that. Okay, so we normally have the graph equal to 0. So let me cut this out and borrow it down at the bottom. Copy, paste. It says greater than 0. I don't know whether I'll be able to actually to write on this picture. Okay, well, let's just ignore that timer. Right, let me see if I can do this. Bismillah. I can. That's lovely. Lovely. Okay, right, let's move this up a bit. Okay, fantastic. This y-axis is also known as what?
0. Or x.
The y-axis. Okay, sorry, I might write down the wrong thing. The x-axis is known as the y equals 0 line. Normally, when we do the question, we do 2x squared plus 3x minus 2 equals y. And y is equal to what?
0.
0. Now, but in here, y is not equal to 0. They want what do they want?
Y is larger than 0.
Okay, so y we got here. Sorry, let me just make sure. Y, yeah, that's right, because that's equal to the one part where is more than 0. The more than 0 will be where? So let's get some highlighters out. Is it going to be, if that's y, because isn't this more than 0?
Yeah, anything above the y.
Okay, and then similarly, if we looked over here, wouldn't this area over here be y is less than 0?
Yes.
Okay, so which part of the graph are we interested in?
The blue part, the top part.
The top part of the graph. Oh, I'm sorry, let me get the right highlighter. So we're talking about, we are talking about this part of the graph and this part of the graph, which basically means we are talking about that part because this is where the value is. Okay, so we are talking about, in reality, x is being greater than a half, and x is going to be what?
Less than minus
Less
2.
than minus 2. So rather than us having the standard nice and easy peasy lemon squeezy standard answer x equals a half and x equals -2, we're going to have to interpret that as x is greater than a half, because that's the values where x is greater than a half are giving all the answers above the graph, above this line. And all the numbers which are less than -2 are the ones which are generating that part of the graph. So we have to adjust our equal sign from basic to our inequality version. And then x2 will be, what's the other one? Less than -2. And that's the answer.
You wrote both of them. On the
Absolutely, yes, absolutely.
Okay.
So I solved the equation. Normally we would have written down x1 equals a half, x2 equals -2, but here we're writing x is greater than a half and x is less than -2. Two separate inequalities. We can't actually join them together because they're not bound together. They are actually two separate answers. If you wanted to, we could write x1 and x2, put a little comma. So that's two separate answers. And that's that question done with a bit of visualization thrown in. Visualization and adjusting the equal sign to look for the inequality. And we are done for today. Right, let's just quickly stop the recording. Okay.